Good evening. My name is Daniela López de Luis from Buenos Aires, Argentina. I will present the project Kronos, corresponding to the accepted paper with title Risk Prediction Based on Time and GPS Patterns. Traffic produces material lost, human injuries, or even persons' deaths. Currently, risk predictors for traffic are reduced, since most of the approaches try to model traffic accidents using traditional information and avoiding some other like environment elements, driver profile, weather regulations, eventual circumstances like strikes with roadblocks, street reparations, railroads, crossings, etc. Besides, risk is very complex to model. For better results, it is mandatory to manage information in a way that allows learning upon time and mainly be able to evaluate patterns related to time periods. Finally, most of the models focus on drivers, information about pedestrian status, and the incident moment is not considered. This project focuses on a model risk prediction, adding information that is not classically included, like weather and time. Other goal is to evaluate the impact of varying geographical information details on the precision of the underlying inference system. The inference system is a soft computing model based on a ruled expert system and an harmonic system focused on time patterns of events. But the harmonic systems is out of the scope of this presentation and paper. The Flex intend to outline a working model implemented as a prototype named Kronos and a statistic evaluation of its sensibility to dynamic GPS information. The architecture is uh, organized as a server with many remote clients connected by cell phones. As can be seen, the prototype collects data from many sources. Then an expert system interacts with its knowledge database, and an intelligent harmonic system meant a similar task in parallel. Main components are web. It is a source of information. A web server, web service, a local server, or other host may connect with the prototype using a proper interface represented in the picture as a Google map, weather information, police stations data, etc. Host. The prototype has a rule-based expert system for data prediction in order to evaluate risk based on expert knowledge, inputs, and historical statistics. It interacts with the harmonic systems to dynamically build a more precise model. Input devices. Information regarding current position, status, and requests may be provided to the prototype by one or more mobile devices, sensors, etc. Each one requires a specific interface that here is denoted as individual and remote device. Output devices. As it may be used by pedestrians and drivers, it is expected to output information upon requests through mobile devices interfaces. They are also represented here as the individual and remote device. External system. Already existent systems may interact with the prototype using an interface. They are not represented in the architecture since it has not been yet implemented. database management system. It is a Postgres database with a set of stored procedures and triggers that automatically checks and transforms data. The prototype requires the knowledge database to be populated first. The specific expert rules are drilled off from real incidents by using classical data mining approaches, such as induction trees and clustering methods. As the harmonic system is not under the scope of this paper, it has been deactivated for testing purposes. To make the prototype work, the system is initialized with certain a priori information about time zones and maps of cities with average risk levels. The user uh, uses the cell phone to connect to Kronos, and automatically the prototype evaluates the GPS location, uploads the zone map, and activates the expert system. Every n seconds, the expert system will evaluate the risk level according to its parameters and knowledge database, and sends the current risk to the user. The processing is online and real time. The original risk of the zone is changed with expert rules on the fly and considering new parameters that will be mentioned in the following slides. There is also a learning module that compiles data to improve predictions. All the dataset belong to real situations of traffic in the city named Concepción del Uruguay, Entre Ríos, Argentina. The figure shows the map of the city. As can be seen, the map has a grid. Each cell represents a smaller zone described in the database as follows: ID zone, description, latitude, longitude, and risk. ID zone is an integer that identifies the cell. Description outlines the zone. Every zone is labeled with global risk extracted from a previous mining process as M, N, A, or left blank. The meaning of each one of these labels is in the next slide. The tables details the meaning of every label in the map zone. A means high risk. M means medium risk. N means no risk. And when there's no label, that means there's low risk. In this table, column disk description field has the values C for center, R roundabout, O country road, or Z country zone. Column S means subject and has the values D for driver or P for pedestrian. In the other columns are date, time, weather information, for example, if it is sunny, foggy, etc., velocity in kilometers per hour, and additional classical information as helmet and belt. The last column defines the alcohol degree in blood. The risk is in the first column. As mentioned in the previous slide, the number relates to the risk levels, and they are 0, no risk; 1 and 2, high risk; 3, medium risk; 4 and 5, low risk. More results, but only for pedestrians, are in this slide. Velocity and helmet belt are not included. The interesting thing is that the alcohol in blood is also considered. The test set are risk situations evaluated post-mortem to be able to find the accuracy of risk according to an expert and the expert system with and without GMT information. Here, expert eh, expert prediction is denoted as E, the line in blue. Expert system without GMT with not G is in red. And the last, the expert system with GMT, is denoted as G in black. This paper presents an outline of the Kronos project, a prototype of a model with a dual risk evaluation mainly using statistical and heuristic approaches. Basic statistical information was presented regarding how the statistic inference can be improved using GPS information. The comparison between the accuracy acquired in previous work has increased in 52%, and it is possible to say that GPS information has a good impact in the results. This trend must be verified with a larger number of test cases. As a future work, it remains to test harmonic systems as it was performed with the expert system and find out how both perspectives may be combined to provide better results. Thank you very much for your time and attention.